This is an overview of the LIT and how it works with the FOGRod. There's a separate video of the FOGRod toughness on our website and on YouTube. The unit here is the LIT, or Level Indicator Transmitter. And this unit is a simulator box. With these 10 switches, I can simulate level on each of the 10 contacts on the FOGRod. These lights here show the status of the 10 level relays and the 2 fault relays. The FOGRod hangs in the wet well from its own cable, and it's connected to the LIT by the colour-coded cable wired into the colour-coded terminals. The FOGRod is a super simple device. 10 metal contacts down the length of a CPVC rod, each contact connected to one core of 10 core cable. The LIT puts a small voltage on each core and looks for current flow to ground. When a metal contact is dry, no current flows. When water covers a contact, current flows through the water to ground. It's just like a light switch, where the water is the switch. So the FOGRod has got no moving parts, no sensors and no electronics. This makes it very tough with nothing to go wrong, and also very easy to understand and troubleshoot. It's just like 10 pieces of cable hanging in the well, held in place with CPVC pipe. In this video, so we can simulate unusual effects, the LIT is connected to the simulator box. First of all, in this video, we'll see normal operation, and then we will look at what happens with grease buildup and other problems. So let's cycle power to the LIT, and what you'll see is all the lights come on, and then the version number shown by one light after another. So that was 1.7. And then the power light comes on and we see the level in the well. Now we're currently simulating one FOGRod contact being covered, so the 10% level LED is lit up and the first level relay is turned on. Level moves up to the second contact, we get the second level indication on the unit, and we get the second level relay turning on. And so on. As we keep going up, the level goes up the FOGRod, we get a visual indication, and we turn on a relay. So it's like we have 10 floats 6 inches apart, or 9 inches apart with the longer FOGRod, but without the pain of all those floats tangling up. We can use any of the 10 level relays to replace our floats. In this video, we've got all 10 level relays wired up, so we can see what's going on. But in a typical float replacement, like this example, only 4 relays would be wired into the control panel to replace off, lead start, lag start and alarm. Let's say you're using contact 1 on the FOGRod for pump off. So relay 1 is your pump off relay. All you have to do is find where the off float wires land in the control panel, disconnect them and wire relay 1 from the LIT into the exact same spot. Let's say using contact 5 on the FOGRod for lead start, so relay 5 is your lead start relay. What you've got to do is find where the lead float wires land in the control panel, disconnect them and wire relay 5 from the LIT into the exact same spot. Likewise for lag start and alarm. We recommend keeping one of your floats as an independent backup, a high level alarm above the top of the FOGRod. It's nice simple redundancy. You already have the float, and floats are very reliable when they're not in wastewater. We also have an analog output. The analog increases by 1 milliamp for each contact that is covered. There's another video specifically on the analog output. You can use the analog to control your station if you're replacing a pressure transducer, bubbler or ultrasonic. If you're replacing floats and using the level relays for control, you can connect the analog to telemetry, if you have it, and view your level remotely. Now, last point about the basic operation of the LIT is powered from 12 volts or 24 volts. The reason for this is to make the system more reliable. When lightning strikes the panel, the DC power supply is likely to take the hit instead of the LIT, and you can find a replacement power supply from just about anywhere, and they're very inexpensive. We have this power supply here on our price list for $50. It's slim, DIN rail mounted and easy to wire up. Now when you wire up the LIT, you must connect up control panel ground to the LIT ground input here. That's because current flows from these terminals here, through the FOGRod, through the water in the wet well, to the concrete and steel of the wet well, and back to the control panel. So if you don't connect up the ground, you won't have a current return and the system won't work. The good news is if you forget, you'll find out straight away when you try and get the system running. You won't get any level LED lights when you turn the power on. So that's normal operation, simple to connect up, simple to understand. But what about problems? Wastewater lift stations are nasty environments, and just about everything seems to have a way of failing. How do we make sure the pumps always stop when the level gets to the bottom of the FOGRod? That's actually one of the great strengths of conductivity, unlike every other level device. Floats can get stuck in position, transducers can fail at a specific milliamp reading, and ultrasonics can read level that isn't there due to false echoes. For conductivity, when the level drops below the bottom of the FOGRod, no current flows to ground. You'd always get an off signal. That's because there's no way for 5 volts to jump through fresh air from the bottom FOGRod contact to the water below. They'll be breaking the laws of physics. So once the level's dropped off the bottom of the rod, you'll always get an off signal and you'll always be stopping your pumps. You'll never run your pumps dry. How do we make sure the pumps always start? Let's increase level in the wet well. And let's suppose relay 5 is wired to our lead start. But let's suppose that because that's the high water mark, that's the worst grease buildup on contact 5, let's suppose that grease is so thick and it's so bad the contact's insulated from the water. So the level reaches the 5th contact, nothing happens. Disaster. Level keeps rising and we reach the 6th contact, which is relatively clean because it's above the usual lead start point. Let's see what happens. The LIT registers contact number 6. You can see that all the level relays up to and including number 6 are on. So that means relay 5's on, which means the lead pump has actually started, just a little bit later. So it's like a backup float, but without the pain and suffering of extra floats. We see that LED for 50% level for the 5th contact is flashing, and we see we've got the wiring or contact fault alarm on the unit, and this fault relay wired to this light is turned on. So you could wire that into telemetry or into a red light on the panel, but it's not an emergency, it's an early warning that you need to do something. So effectively we've got a lot of backups in this system. We're always going to turn the pumps on. Now in the example I gave, it was grease insulating the contact. How do we fix it? Well, unlike floats, which are a pain to clean, the FOGRod's very simple. It hangs from the mounting bracket by its own cable, and the mounting bracket has a wiper or a squeegee as part of the bracket. Pull the FOGRod up through the wiper, hang the FOGRod back in the well, and you're done. Now let's suppose there was a fault in the system, and when you hang the rod back in the wet well, the alarm comes back on. Troubleshooting's simple. Get a jumper wire and connect FOGRod input 5 to ground. Does the 5th LED come on? If it does, the LIT is working okay. Get an ohm meter, a multimeter set to resistance, and test the resistance between core 5 of the FOGRod, which you disconnect from the LIT, and touch the other end of the multimeter to contact number 5 on the FOGRod and check the resistance. Is it a few ohms? Very simple. It's just like troubleshooting a light bulb that doesn't come on. So we've seen that we always detect low level and get an off signal, and we've seen that we've got plenty of backups for our lead start and our lag start, so we're always going to start the pumps. The FOGRod itself anyway has really got nothing to go wrong. It's just 10 pieces of wire hanging in the wet well, so we'll always start the pumps. The remaining problem, which is actually the main problem for a conductivity rod, is grease buildup. And in usual lift stations, what happens is it starts to short out adjacent contacts, especially around the lead start point, because it holds water inside it. It's not that common to find that grease insulates the contact from the water, like in the last problem that we looked at. If you've installed the FOGRod in the more turbulent part of the well, near the inflow, where all the grease is broken up, the grease buildup on the rod will not usually insulate a contact. In fact, that's the recommended place to install the FOGRod, because that's where you'll get the least problems. As the buildup gets bigger and bigger, eventually with water held inside, it starts to short out adjacent contacts. You can't tell by looking at a FOGRod and looking at the grease whether it's going to cause a problem or not. And this is one of the unique features of the FOGRod and the LIT. We detect this problem, give you an alarm so you know the rod needs cleaning, and prevent it from causing short cycling of pumps. This is one of the ideas that Wastewater Level has patented. Let's see how it works. So we'll reduce level down in the well, down to say 20%, so the second contact is underwater. The clean FOGRod switch needs to be in the on position. If we leave it in the off position, it doesn't detect this fault. Now let's say we get to contact number 3, and because of the water held inside grease, it shorts all the way up to contact 5. Now, if we didn't have this feature here, what we'd be doing is we'd be starting the lead pump when we're only at 30%. So we'd be short cycling the pumps. What we can see is we've got relay 3's come on, but relay 4 and 5 hasn't. And the clean FOGRod light flashing indicates that we've started a timer. And the LIT level detection says 30%. It knows the level when that was first detected was really only at 30%. Now I'm going to pause the video and resume when the timer ends. Okay, so we see that at the end of the timer period, relays 4 and 5 have come on. So now the lead pump will start. And level LEDs 3, 4 and 5, 30% to 50% are flashing to show where the problem's located. The clean FOGRod alarm is on solidly, and the fault relay has latched on. So this means you can't short cycle your pumps. You've got a 3-minute delay between off and lead start when this fault is triggered. Now we've got another video specifically about version 1.7 that goes into all the details, so please check that out. When you come to site and see this alarm on the unit, you know you need to clean the FOGRod. As before, it's easy to do. Just pull it up through the squeegee and put it back in the well. Then clear the alarm by flicking the dip switch to off and back to on. Now the other reason why this alarm can be triggered is rags shorting out the contacts. Each FOGRod contact is offset by 120 degrees from the one above to minimize this, but it can happen. And people ask me, how often does it need cleaning because of grease buildup? The answer varies widely depending on the station, the amount of grease, and the location of the FOGRod in the wet well. The worst wells might need the FOGRod cleaning every few weeks, and the best ones never need the FOGRod to be cleaned. But there's no right general answer to that question. Now that's almost it on the FOGRod and the LIT. There's one last condition we monitor for, and that's the cable. We've got 10 metal contacts on the FOGRod, but we've got 11 cores of cable. There's the 11th, which we call FS. And the last core is a loopback test. So I'm going to disconnect that core. Imagine the cable's broken. And what happens is there's a 10-second delay, so we don't get any spurious alarms. It waits full 10 seconds and checks that that's continuously open, and then it gives us a fail-safe open circuit. And we change this. This is an older version of the unit. We change this now to say cable open circuit, so there's no confusion about what it means. And we've activated the other fault relay, so this fault relay here has been turned on. Now this is just a once in a blue moon event, but of course you want to know if the cable's been damaged. I'll wire that back in. Now, what about checking up on the LIT itself? What happens if power fails to the LIT or the LIT fails? Everything electronic ultimately fails. It might take 30 years, but eventually it will happen. What we can do with the fault relays, and I recommend it, is to set them using this dip switch to be normally closed. Now we see that with no fault conditions, both of these fault relays are actually on. So you just tell your telemetry system that on means good, and when a relay opens, it's bad. So if we lose power, here's what happens. Both of those relays spring open. Power and software were holding them shut. So you can tell your telemetry system, a white or red light on top of the panel, that both relays open means the system has lost power or failed. That's basically it. I hope people watching now have a good overview of how the LIT and the FOGRod work and why it's a great system for lift stations. The concept is simplicity, and we've made it easy to wire up. The software inside the unit tells you when there's a problem, but when there is a problem, it keeps everything working as close as possible to normal. Thanks for watching this video. We offer free trials to municipals, so please give us a call. 406 545 3023.